so this is the second part in section 9, okay? We'll talk about the interest, okay? So this is on page 119. Okay, we'll learn different types of the interest, compute interest questions, okay? So the first type is called a simple interest, okay? I'm going to ask a volunteer to read everything from here to, okay, above the question 1, okay? So who's turn?
If money were invested at simple interest, then each year you would earn interest only on the original amount of the principal that you invested. A simple example, single deposit, simple interest, consider a deposit of $1,000 earning simple interest of 4% per year. The interest is 4% of $1,000 equals 1,000 times 0.4 times 1 equals $40 every year. The ending balance would be $1,000 plus $40 equals $1,040. Convert percentages to decimal form before they are used in the calculation.
Very good, thanks. Have you read the grade table? This table, simple interest equals, have you read this?
No. Simple interest equals principal times rate times time. I equals PRT.
Very good, thanks, okay. All right, so simple interest, okay. If we do the calculation, okay, we compute what? The interest only on the original amount or the principal that we invested, okay? And the formula to compute a simple interest is this, okay? Simple interest principal, which is our original amount, times by the rate. Here, this rate must be in the annual rate, okay? This rate must be in annual rate. Okay, and then times by what? The time period, okay? And this time period must be also in years. Okay, so for example, I'm going to deposit $1,000 with this interest, annual rate for a year. So the T, okay, I equals P for principal, R for rate, T for time, okay? T will be 1, okay? Because we know this is for 1 year, right? How about if I deposit money for the same amount with the same annual rate but only for 9 months? Are we going to replace this T by 9? No. Okay? We have to make sure this time is in years. So how much of a year is for 9 months? There are 12 months for a year. Yes. 9 out of 12 give us 75%, which is 0.75 of a year. So if we encounter calculations like this, we will have to replace T by 0.75 of a year, not 9 months, not 9, okay? Because if we replace T by 9, it gives us 9 for what? 9 months, okay? So here, we have to make sure that the time must be in years. If they're not given by an integer years, we have to convert them to in years, and this rate must be what? An annual rate, okay? Annual interest rate. And here, okay, convert the rate to what? Decimal number during calculation, okay? During calculation. Well, see the example. This example telling us $1,000 deposit, which is our principal, times by what? The annual interest rate is 0.04, see 4%, converted to decimal number 0.04. For how long? For 1 year times by 1. And then it gives us what? $40, okay? So that means this is what? The interest amount we earn by using what? The simple interest. For $1,000 and with a 4% annual rate, okay? And what will be our ending balance, guys? Ending balance will equals what? The principal, which is $1,000, plus this actual interest amount we earn, which is $40, and it gives us what? $1,040. Okay? See, you have to really pay attention to the question. If the question only asks you how much interest will you earn, then you only compute what? The interest. Okay? okay? And then if the question asking you, what will be the ending balance, what do? We add up the principal by what? The interest amount. That gives us the ending balance, okay? All right, guys, now let's try question 1 and 2 together. How much interest would be earned in 3 years? If we still deposit $1,000 with an annual rate of 4%, how much interest will we get? I equals what? PRT, right? What is the principal? What is annual rate? What is the time? Years. 3. Use your calculator and tell me your answer.
$120.
You get $120? Okay. So that's the interest amount, right? Question 2, what will be the balance after 3 years? Principal plus interest amount, ending balance, $1,120, right? Okay, what do you feel about simple interest? It's pretty straightforward, right? Just make sure that we know this formula, okay? So I believe these formulas are on our yellow sheet. If you have a yellow sheet, you can double check, okay? So that means this formula will be given to you in your exam, but you have to know how to apply it, okay? Apply the formula and then do the calculation, okay? Okay, so that's a simple interest, okay? I'm going to ask another volunteer read these 2 paragraphs. Leila?
The simple interest model adds the same interest value each time period. The kind of growth is adding the same value each year and is linear. Simple interest is generally used only on short-term loans. Most long-term investments do not use simple interest. It is more realistic to think in terms of compound interest.
Very good, thanks, okay? So, linear models, well, linear interest is linear, okay? Yeah, well, simple interest is linear, sorry, okay? Simple interest is linear, okay? However, okay, the majority of the cases that the money we input in a bank, they don't give us simple interest, amount. We use what? Compound interest, okay? So simple interest is very tiny type of the, interest type of the question, okay? Majority of the questions are in compound interest, okay? So now let's turn to page 120, okay? And then we look at compound annually question, okay? So this formula, it's about compounding annually. Okay, so I'm going to ask a volunteer to read all of these. Okay, whose turn? Stephanie?
When money is invested earning compound interest, it earns interest not only on the principal but also on the accumulated interest of previous periods. This is sometimes described as earning interest on interest. For now, we will assume that interest will be calculated once per year. It is important to remember that compound interest savings accounts are based on a single lump sum deposit into an interest-bearing account. Each time the interest compounds, the investment is multiplied by 1 plus the interest rate. This results in the following formula for the balance on the account. Annually compounded interest balance equals principal times 1 plus rate time. Notice the compound interest model applies by the same growth factor every time period. This kind of growth increases quickly from year to year. It is
exponential, right? Okay, very good, thanks. Okay, for compound interest question, okay, so there are 2 formulas we need to master. Okay, this is the first one, okay? Annual compound interest. Okay, let's look at this model. Okay, the model is telling us in order to compute the balance, okay, it equals principal times by 1 plus the rate to the times period. What do you think about this formula? Do you feel familiar? Remember the exponential model we just learned? Okay, initial amount, which is a principal, times by what? 1 plus the percentage change. What is 1 plus percentage change? This gives us what? Growth factor, right? So that's why I said compound interest model multiplied by the same growth factor. 1 plus rate, this is a growth factor. Okay. And then to the times period. And then this time must be in what? In years, okay? In years, okay? And then this model, compound models are, this model is exponential, okay? All right, so now let's look at an example directly, okay? So hopefully that will help us to understand this model better, okay? All right. Consider initial deposit of $1,000. We're still having 4% annually rate, okay? But now earning compound interest, okay? Not simple anymore, compound interest, okay? Fill this table below for 3 to 5 years, okay? Year 3 to 5. Don't forget that you're calculating dollars, so round to the nearest. The penny means hundreds, right? Round to the cents, right? Determine the amount of accumulated interest earned. We can subtract the original principal. So let's fill out this table together, okay? So if in year 0 we have $1,000, initial amount is $1,000. At the end of year 1, okay, so let's say this is year 1, what will be the ending balance, guys? 1,000 times by 1 plus 0.04, right? Or 1,000 times by 1.04. Because every year we have a 4% increase, right? That's our percentage change. At the end of year 2, what will be the ending balance? Just like that Oliver question, remember Oliver has deposited like 6% more each year, you know, right? So at the end of the second year, he should have 1,000 times by 1.04 to the second power, give us this. Can you do this? This is 1,000 times by 1.04 to the cube, right? And this is 1,000, 1.04 to the fourth power, fifth power. Use a calculator, okay? Compute these exponent and then multiply by 1,000. You have to practice, guys, because your exams, if you know how to do the problem but you don't know how to type in your calculator, you might lose credit, okay? So make sure you're able to practice in class, okay? Because if you practice enough in class, you will feel, in the exam, that question is the same thing as, we practice in class. You won't feel that, you will feel much comfortable if you practice in class, okay? And I will let you tell me, what are these numbers? So Andrew, how about you tell us these numbers? What do you get here for the third year?
1,124.86.
100 or 100?
1,124.86.
0.86, right? And then here?
1,169.86.
86. And then the last one is
1,216.65.
16.65, right? Everybody, do you get the same answer? Okay. All right. So we haven't done here. Okay, we haven't done here. So let's answer the questions. Okay. How much interest was earned in the first year? Initial deposit is $1,000. At the end of year 1, balance is 1,040. So what is the interest earned in the first year, during the first year? Ending balance minus principal give us what? Interest we earned during the first year, in the first year. So what is it? $40. Do you see that? $40. How much interest was earned during the second year, not including the interest earned previously. How much more is this than the first year? Okay. Now let's look at this, let's check this column. 1,081.6 minus $1,000, we have this $81.60. What does this amount mean? This is the interest earned in the first year. Oh, how about this amount? Can we say this is the interest we earned during the second year? Or during the first 2 years, right? Yeah, because this is the initial amount, after 2 years, ending balance. So this 81.60 is interest in the first 2 years, okay? So we'll say interest in the first 2 years. In total, in the first 2 years, we earn $81.60. Now the question for you is, how much interest was earned during the second year? In total for those 2 years, 81.6. In the first year only, $40. So what will be the interest during the second year? Yeah, 81.6 minus 40, right? $41.6 during the second year. How much more is this than the first year? How much more? $1.60. Okay? Guys, do you see that? This 81.6 is not just for the second year, it's for the first 2 years. Question 3. How much interest was earned during the 5th year? How much more is this than the first year? Okay, 5th year. So let's compute this, table. Okay, so accumulated interest. Okay, so this line we use this number minus 1,000. How about this line? We use ending balance after the 3rd year minus principal, give us what? 124.86. This is what? The interest earned for the first 3 years in total, right? 1169.86. 169.86. This is interest earned in the first 4 years total. Okay. This is the interest earned in the first 5 years in total, right? What are we looking for? During the 5th year, how to get this amount during the 5th year? First 5 years, first 4 years. So how to find the fifth one? The difference between these two, guys, do you see that? The difference between these two numbers give us the 5th year interest amount, okay? So we use 216.65 minus 169.86. 46 point what? 79. Everybody get the same answer?
No.
So this is interest during the 5th year. Okay, how much more is this than the first year?
$6.79.
$6.79. First year and this March, second year is this March slightly more than the first year. You can compute the second. What's the interest earned during the second year. Use this number, subtract by that number, get the during the second year. This one minus that, give us during the what? This is year one. Oh, this is the difference between this give us second year, the difference give us during the third year, during the year 4, okay, during the 5th year, okay. So you will see that each year, okay, this interest amount is slightly more than in the previous year, a little bit more, okay? Because for compound interest, we're not just compute the interest that depends on the principal. We also compute the interest depends on what? Accumulated balance, okay? Accumulated balance. Okay, so this is on page 120, okay? But I need you guys to really understand this formula, and then when the formula is given to you, okay, you know how to apply it, okay, apply for it. All right, so now let's move on to page 122. Yeah, those practice questions, I will let you guys try them by yourself, because once we know how to apply to the formulas, you just need to practice more, okay? This is on page 122. Compound interest periodically, okay? So I'm going to ask a volunteer read this short paragraph above the grade table and also including the grade table. Kathleen?
Not all compounding is annual, often compounding is quarterly, monthly, or even daily. The concept is the same, just divide the annual percentage rate by the number of compounding periods and convert the years to the total number of periods. Balance equals principal 1 plus interest rate over times
Number of times.
number of times compounding each year.
Yes. Number of times compounding each year.
Number of years times
Okay.
the number of years.
Very good, thanks. Now let's use this formula and then to work on questions, okay, on the questions, okay. All right, so what does compound periodically? See the example, compounding quarterly. If we say we're compounding quarterly, that means every quarter they give us what? An interest, okay? So this compounding occur how many times each year? 4 times, okay? Compounding yearly means they only give us interest for every year, okay? Every year only give us once. If we compounding quarterly, that means after each quarter they give us a amount of interest. So the compounding occurs 4 times. If we say we're compounding monthly, every month they give us amount of interest. So how many times this occur? 12 times. How about the compounding daily? 365. Okay, you may ask, how do I use like 365 or 366? Some years we have 366. Well, I would say that let's use 365 if it doesn't say this year has how many days. But what I know is for most of the banks, they use 360 for daily. Okay, it's just by default in the bank. Okay, so it really depends on the question. Okay, if the question doesn't say daily, compounding daily equals how many days, you just use 365. Okay, if it says, okay, it's a blank or blah blah, okay, so let's use 360 as the, full year, then we use 360. Okay, if it said, I don't think we use 366. Okay, that's very rare. Okay, either bank or like us, we don't use 366. So either 365 or 360. So if it doesn't say anything, 365. If it says 360, use 360. Okay. All right. So now let's work on the question. Okay. This example. $100 is invested for 3 years, so we know the number of years is 3. With APR means annual, what is this P for? What? APR? Percentage rate, yes, whatever. Yeah, APR, we'll talk about this in the next section 10, okay? But this is annual, A means annual, okay? 11%, which is 0.11. Compounded quarterly means what? The number of compounding each year is what? 4. So you know that, we divide the annual rate by 4 times. Okay? So, how do you compute the balance? Plug in principal 100 times by parentheses 1 plus any rate 0.11 divided by number of compounding, which is that? What is that? 4 to the what? Number of times compounding, which is 4 times by 3 years. Okay. Well, the thing is, how to compute this result? We really have to pay the order of, or pay attention to the order of operations. Okay. You know, if we have parentheses, we do parentheses at first, right? And then we have exponent, then we have multiplication, division, then we have what? Addition, subtraction. Okay. So in this line, do we have a parentheses? Yes, we do, right? So we have to do with the parentheses at first, right? Inside of parentheses. Now, inside of parentheses, we have addition, we have division. Which operation do we should do at first? Division. So use your calculator, type in 0.11 divided by 4. Then add your answer by 1. What do you get? Please tell me. 1 point something, right? Well, here you can keep as many digits as possible, and well, for some calculator, if you can type in the entire line, entire thing, that's more accurate. But yeah, yes, let's round, but let's keep more digits because we want to make the final answer as much accurate as possible. So give me like 4 or 5 digits.
1.028.
1.028.
That's rounded.
Oh, that's rounded?
Yeah.
Okay, 1.028. Okay, let's use it. And then what's going to be the exponent? 12. So 100 times this number to the 12th power. We have to do what? The exponent first, okay? So that's why, okay, just now you round, but you don't have to round during your calculation. You just use whatever you get from your calculator and then to the what? 12th power. Once you get that answer, don't round, multiply your result by what? 100. So do a more accurate calculation, please. Division plus 1, result to the 12th power, and then the result by times by 100, and then see what you get. You'll get. Or can I borrow anyone's calculator if you don't know how to do that? I can. Kathleen, let me use your calculator to show everybody. Okay. So 0.11. Oh, it's not on. 0.11 divided by 4, see, this, plus 1, 1.0275. I will keep this 1.0275 if we are still be able to write. These are only 4 digits, right? Then we need to the what? 12th power. Where's the hat? To the what? 12th power. I didn't round, okay? And this gives us, we didn't round that either. Okay. And then we need to multiply this result by what? 100. Answer is 138.448. Okay, so 138.48 if we round to the cents. See, I don't think the text will round during the calculation because if you round, very likely your answer will be slightly different from the most accurate answer. So since you have a calculator, just don't round during calculation. Okay. All right, so let's practice one more question, okay? Then you can practice, all right? Question 1, let's try question 1C, please. $2,000 is invested at the annual rate 6% for 8 years. Calculate the balance if the account is compounded daily. How to set up the calculation according to the formula?
2,000 times
balance equals 2,000 times by parentheses 1 plus what?
0.06.
0.06. Make sure it's in decimal number. Divide by
365.
Yeah, compounding means every day they give you amount, and it occurs 365 times. Okay, times 365 times what? 8 years. Okay, so let's do the calculation, okay? Because this exponent is a huge number, so I will compute this result at first. before we do the entire calculation, okay? So I would say do 365 times by what? 8. 2920. That means the exponent will be 2920. You guys see that? Okay. Then let's do the entire calculation, okay? All the operation, guys, start from the division this, okay? So 0.06 divided by what? 365. Add this result by what? By 1. Add 1. This number we do round. Okay. So this is the result from the parentheses to the what? 2,920's power, to the power, here, to the 2920's power, give us this number, we do round, and then eventually multiply the result by what? 2,000 times by 2,000. .02. Okay. So 3232.02. Right? Alright, so this is a compound periodically, okay, periodically, okay. Okay, so this is a third formula I need you guys to master, okay. So if we summarize, okay, what are the 3 formulas we learned so far for the interest part? One formula is what? The first one is what? Simple interest, right? I equals PRT, but that gives us the interest amount. We have to add this interest amount to the principal. That gives us the ending balance, right? Second type is what? Compounding annually, right? Use that second formula. What is the third type? Compounding periodically, okay?